Okay. Now we can start.
Okay. So today our group will present a report. The title is Friction on Inclined Plane. So my name is Aiman Arif bin Musa. My metric number is AD220007.
My name is Idun Feng, and matrix number is AD220135.
And my name is Fu Yuheng, AD220.
My name is Hishman Vinayaga, metric number AD220101.
And my name is Kok Wei Song, and my metric number is AD220142.
So can you go to the next slide? So I will explain the additional theory. An inclined plane is a straightforward device with a sloping surface that is used to lift heavy objects. When a friction is taken into account, the force needed to move an object up and incline is less than the weight being raised. The needed force is closer to the real weight the higher the slope or incline. Thus, Galileo was able to precisely measure acceleration using straightforward instruments thanks to the inclined plane, which ultimately allowed him to demonstrate that gravity is what causes all failing objects to accelerate toward Earth uniformly at the same rate in the absence of other force like air resistance. A mass particle will slide down a smooth inclined plane if it is released onto it with a friction force F equal to 0. So we resolve in the direction of motion to determine the particle's acceleration as it slides. The amount of force required to move an object up an inclined plane as opposed to vertically is less, but the object must be moved a greater distance. As a result, the mechanical effort required to lift an object vertically equal the effort required to move it up an inclined plane. So this is a diagram of the inclined plane, which is have a mass m, mass of the block, g, acceleration due to gravity, and angle of elevation of the plane measured from the horizontal. Next slide. The mechanical advantage of an inclined plane is the ratio of the length of the slope surface to the height it spans. It may also be expressed as the consequence of the angle between the plane and the horizontal. A simple physics exercise can help to understand the inclined plane. It is possible to mathematically describe the force acting on an object when it is placed on an inclined plane. So there are three forces at work on the body. The first one is the normal force exerted by the plane onto the body, and mg, the force due to the gravity, and F, frictional force of the inclined plane. So the gravitational force may be visual as having two components. The first one is a force parallel to the plane, mg sin theta, and a force acting into the plane, mg cos theta, which is equal and opposite to n, which is a normal force. If the force acting parallel to the plane, mg sin theta, is greater than the frictional force, then the body will slide down the inclined plane. Otherwise, it will remain stationary. When the slope angle is 0, sin theta is also 0, so the body does not move.
So this is the result for our experiment. Sheet for us to record the result for test 1 to test 6. We are recording the value of the angle of inclination of plane and the applied force.
Next slide.
Next slide, please. So these are the calculation for the applied force by calculation part. The working steps to calculate the applied force according to the angle of friction, which is 0 degree, 10 degree, 20 degree, 30 degree, and lastly 45 degree. That's all for the result and calculation part.
Okay, as for the observation, in all the 8 tests, 8 different observation was observed. In test 1, the block was moving in a slow uniform speed after a starting push is given to overcome the static friction. The same load was hung on it and the angle of friction was recorded. In test 2, the angle of plane from test 1 was not altered. The weight is increased until the block moves in a slow uniform speed and the weight was recorded. In test 3, the angle was changed to 0 degrees. The load was increased to 0.04 Newton to make the wooden block move, and weight was recorded. In test 4, angle was increased to 10 degrees. Load was increased to 0.3 Newton and weight was recorded. In test 5, angle was increased to 15 degrees. Load was increased to 0.43 Newton to make the wooden block move, and the weight was recorded. In test 6, 7, and 8, the angle was progressively increased until 45 degrees, and the load was also increased until 1 Newton to make the wooden block move in a uniform speed, and the weight was recorded in the end.
So now is my part. And for the discussion, the first question is to discuss the value of T obtained by experiment and calculations, and compare those values with the force S acting down the plane. Because it is an experiment, so the result will be different to the calculation part, and due to some error and limitations while carrying out the experiment. Both the experiment and calculation value for the P are heavier than the force acting down the plane. But the calculated value, and the second question is suggest some reason why they are difference occurs between the value of P by experiment and by calculations. The first one is the surface between the inclined plane and the sliding object to test are not perfectly uniformly and smooth. So this will affect its roundness, resulting the accuracy of the result decrease. The second is the Paris error occurs. So when taking the reading from the protector, so this will cause the angle of inclination plane is not true or accurate. And the third is the presence of dust, which tend to increase the resistance of the object to slide. The third question is that the difference between the frictions on horizontal plane and frictions on the inclined plane. There are two differences, which is the directions and the magnitude. First, the direction along the direction of the friction on the horizontal plane is parallel to the horizontal surface, but the direction of friction on the inclined plane is parallel to the plane surface, which is an inclined plane. Second, the magnitude. Because the friction equation is equal to the coefficient of friction times the normal reactions. And since the normal reactions on the horizontal plane is the weight of an object, but on the inclined plane, the weight is the normal force is the weight multiplied by the cosine angle of inclination of the plane. So hence I can conclude that the friction on the inclined plane always smaller than the frictions on the horizontal plane. Question part. There are two questions. First is what is the connections between the angle of frictions and the coefficient of friction? The coefficient of friction is equal to the tangent of the angle of frictions. And the second question is explain two engineering applications showing the significance of the frictions on the inclined plane. First is the aircraft takeoff and landing. Second is the vehicle braking system. The first one, the aircraft takeoff and landing, when an aircraft take off or land on an inclined runway, it's necessary to know the coefficients of frictions between the aircraft tire and the runway surface, because it will affect the acceleration and deceleration of the aircraft. So sufficient friction will provide safe and controlled movement for the aircraft during this phase. The second is the vehicle braking system. When the brake is applied, it can help to prevent the vehicle from sliding down the inclined plane. The friction force will decelerate or stop the vehicle so it can stop on the hill. Without sufficient friction force, the wheel will automatically lock off and slide, leading to losing control and causing an accident. So the next one is the conclusion part.
So throughout the experiment, we can successfully determine the coefficient of friction. Second, we are clearly determine the friction on the inclined plane. Furthermore, we are successfully proved that a force required to slide a block out the plane is equal to W, which is sine alpha plus beta cos theta, where alpha is an angle of inclination of plane. So that's all for our group 1 presentation. Thank you for all my group member and Encik Masnabing Isman.
Welcome.